In this video, we're going to look at the PNP bipolar junction transistor current source. We're going to control it with a trimpot, and this is the circuit we're going to look at. And so what we're going to do is set a voltage across the resistor using a trimpot. So we'll have the voltage. Actually, you can see we got the positive side of the power supply on one side of the resistor, and then so that side will be more negative. So the farther we get setting the trimpot away from the positive side of the power supply, we'll use 9 volts for most of the video, if not all of it. Farther we get away, the more voltage difference there will be across the resistor. And then the resistor will set the current through the resistor, transistor, and either the multimeter measuring current or an LED. In this case, it doesn't matter what the load is as long as the power supply has enough power to power that. So if we want more LEDs, we definitely have to use a higher voltage. But in any case, for every volt that is across the 1 kilo ohm resistor right here, it's going to set the current to 1 milliamp. Makes the math easy. If we want to change the current, because 1 milliamp isn't much for a red LED and we can't provide a lot of current, then we could use a 500 ohm resistor. I have 510 ohms, but practically the same. We would get 2 milliamps per volt. I did that with the NPN bipolar junction version of the circuit. If we wanted less current, we could use more resistance. If we double the resistance, we'd get half the current per volt. So now, here's a different diagram, an old diagram, but it has the pin layout of the 2N3906. Right there, flat side, left pin's emitter, middle pin is base, and right pin is collector. So the emitter we're going to put towards the top of the circuit, as you can see in that example circuit here. Another thing, with this sheet, I have some of the properties of different transistors on here. So the 2N3906 and the 2N3904, the NPN version, you want to limit the current to 200 milliamps and power of the total device to 625 milliwatts. That's in the TO92 package, as is the 2N2907 comes in the TO92 package, but it can handle 600 milliamps of current, but again, with the power. So that would be at low voltages, high current. And it has the same pin layout. It also starts with 2N, and then I have a high wattage version of the PNP transistor here. So it can handle 3 amps of current, 12.5 watts. Of course, you need a heatsink for that. I haven't found material that does a great job explaining which heatsink you need, so I just put with proper heatsink. The pin layout for that one is different right there. So it doesn't start with 2N, and it's even a different package than the TO92. TO92 looks like this. And so its emitter is in the same pin, but then the collector is in the middle, and the base is to the right. Otherwise, it works the same. It can just handle more power than these other PNP bipolar junction transistors. So now, the circuit's really easy. We only have 3 components, and then the load. We'll start with the trimpot. It's a 10 kilo ohm trimpot that I'm using. Exact value is not terribly important. There's the resistive element from, in this case, the top pin there and the bottom pin there. The middle pin is offset a little bit right there. The middle pin is the output, the arrow, and then the other 2 pins go to the power supply, and in that way we have more or less resistance from the positive side and the negative side. It outputs a voltage, so not a strong voltage. You need an amplifier like a transistor to transfer that voltage, which is exactly what we do in this video. So now we're going to use 1 kilo ohm resistor because it makes the math easy. Unfortunately, it doesn't provide in this circuit much current for the red LED. We'll talk about that a little bit later, and I jumped ahead of myself, but in any case, doesn't really matter. We just can't see how it connects to the transistor yet, and this should actually be okay. So positive side and then we come one spot away from where the base is, right there. So now we got our PNP, bipolar junction transistor. I already showed the pin layout. So the emitter is the left pin, base is the middle pin, collector is the right pin. So if I turn it this way, now, flat side facing us, like that, now we have the same pin layout you see there. The emitter on top. Or if I put it face down, emitter is still on top. So we're going to put the emitter, that's very important, to the 1 kilo ohm resistor right there. And you can see that. So that's it for the circuit build. Pretty straightforward. And let's now add the multimeter to measure current. So now the power is off. We have to be careful measuring current, but I limited the current of the power supply to 20 milliamps, and we got 9 volts. So that'll protect the meter here. Not all power supplies limit current. And the output's off right now. I have these jumpers. We'll clip them to the probes. So we just have to look at where I'm putting the jumpers. And then so we put the red one towards the more positive side of the circuit. The meter is going to be the load. It provides practically no resistance though. And so it's a no resistance load, but that doesn't matter. We set the current with the resistor as long as enough power is available. So there are the jumpers, and I'm going to set this to measure milliamps before I make my connections. So we got milliamps there. For this meter, I can just leave the probe there, and so it's going to give us the results in milliamps. So connect the black one and the red one. So you can see we're just bridging the gap from the collector there. Now this is a current source. Last video I made the NPN bipolar junction transistor. The transistor was on the more negative side of the load, so we consider that a current sink, even though we call anything that sets a current source usually. Whereas this one, the transistor is on the more positive side. So it is actually a source of current, if you want to get technical. So, in any case, let's turn the power on. Depending on the setting of the trimpot, away from the positive rail. The farther we get, the closer we get to the negative rail, the higher the current is going to get. But you can see that the multimeter and the display on the power supply, I'm going to go more negative right now, so it raises the voltage. They're not terribly far off, but the multimeter is more accurate right there. And so we can just go by this if we just need kind of a general range. So let's stop at about 4 milliamps right there. And what we're going to do is put a red LED in series. So we set it to 4 milliamps. Now we're going to change the load drastically. We're going from no resistance basically to a voltage drop. Remember, the long lead, the anode, has to be more positive. Short lead, the cathode, more negative. And there you can see we got that 4 milliamps of current, just slightly less. The red LED though, it actually kind of looks okay on camera, but I don't have the lamp very bright. When I get the lamp brighter, you can see it's getting harder to see the red LED. So the green LED blocks more voltage. I think we'll be okay right now, but I think we're about at the limits. There you can see exact same current right there. So the green LED blocks more voltage. This arrow pointing to the left is halfway between positive and negative. If I go more negative, we're going to raise the voltage and the current, but at some point you're going to see it level off. And so we can get to 5 milliamps through the LED. And there, we hit the point. Now if I keep turning it down, more voltage is across the resistor, but the current's coming out of the trimpot and going through the resistor, because we just have too much going that way, that it's not letting it through there. I don't know how to explain it perfectly right now, but in any case, there's limits. And so what we could do, we leveled off at about 6 Yeah, just slightly less than 6 milliamps of current. This is a 1 kilo ohm resistor. We can raise the voltage to 12 volts. And I'll zoom back so we can see it all, but there it's 9. And we'll go 10. So there's more current now because we have a higher voltage. So there we go. So now 9 milliamps of current through the LED and the multimeter. Let's see. Actually, it's probably about the same limit. Let's see if I can get up to I won't be able to get to 10 because it's blocking. So yeah, we hit about our limit. So we got more current, but the trim pot was in the same spot. So I didn't do a test run of this before filming. These are I'm discovering these results as I go. So that's one thing about these simple circuits, is that there's a lot to learn from them, testing them out and stuff. Usually you get shown, you know, like a simple schematic like this. I think we're done with any testing I'm going to do. But in any case, I think I covered everything I want to. You start with a simple schematic like this, but there's a lot of electrical principles to learn. Take these measurements and stuff.